Codesignal, Arcade, Strings Rearrangement. Hello Internet, my name is Joshua, and I'll be solving strings rearrangement of Codesignal. Let's get right to it. So you're given an array of equal length strings, and you'd like to know if it's possible to rearrange the order of the elements in a way that each consecutive pair of strings differ by exactly one character, and return true if it's possible, false if not. And in this case, for example, ABA and BBB and BAB. In this case, I believe it's false. So you could tell here that there are different arrangements right here, and see if we could have that desired pattern. I included in the description above, but since it doesn't have that pattern, it looks like it's index specific. It's pretty strict on that one. But you can see right here that if you use something simple like this, AB, BB, and AA, well, actually simplicity doesn't matter. Disregard that. But if you try to rearrange it, you can find a way that there's always at least one character difference that makes it return true. All right, that's good. So I have already written an algorithm for this. I tried to solve it before and I kind of did it. The reason why is because I want to get right through this quickly. So what you need is you need a queue to store all the strings from the input array. Now what this does is that I'll show you how it plays out later. Now I'll create a linked list and initialize it with the first string from the queue. Okay, so I'm going to get with a string from the queue. I'll remove it from this queue and add it to this linked list. So now we have one string to compare with. Now we'll go through the queue, all the strings in the queue, until it finds a word that is a difference with one letter from the word in the linked list. Since it's the only word, it doesn't matter if we want to get the first or last word of the linked list, the linked list of strings, excuse me, because it's going to be the same word. Now, if there's a chance that there's a word has a difference of one letter, and I'll do this by iterating through each corresponding letter based on index. And since we know that the words have all the same length, I think the constraints here are pretty specific about that. That's good, or the description that described that. But if there's going to be a word with at least one difference, we're going to add it to the linked list corresponding to where that word is located. For example, if it's like there's 3 words in here, and we compare with the get first word and get last word, but it has that word with difference of one letter at the get last word, then we want to add it to that back of the list and remove from the queue, because we know that that string, we don't need to check it over again. So basically, this queue tells us what strings we can try to compare with the words in the linked list that we already did matching with, or sort it based on the order right here. So let's just solve it right now. So it's going to be, oh, and by the way, if we go through this whole queue, and we found out this queue didn't change in size, that means that we couldn't remove a string because there's no word with a difference of one letter, then we return false. There's no match. So let's get right to it. So we need a linked list, string, and I'm going to say I'll call it tries equals, let's see, let's load strings. I'm going to create a helper method so that this is going to be kind of clean. You don't really need to create a bunch of helper methods, but I find it easier to understand code. I think you would too if you try this. So it has to return a linked list, but first I have to go ahead and go through the string arrays here, and then I'm going to create a linked list to return. I don't want to make it too stuffy inside this class because I want to know what the heck is going on there. String temp equals new linked list string. Okay. Now for each string in the input, we want temp dot offer string inside the linked list, and then after we're done, we return the whole temporary list. Now we're going to go through the tries. That's going to be let's see here. So it returns a linked list once it's done loading it. Now we also want to create a helper method. So exact one difference. So we're going to compare one word, so the target word with the actual word, and we also want to know how many letters we want to go through. And since we know that the length of each word is the same, we just, well, for this case, we're gonna, oh, I forgot, I need to create a linked list with the matches we have so far. Okay, and now matches dot offer, let's say tries dot poll, which means we remove the head of the linked list right here, tries, and we make it as the first word that we're going to compare with. Now the length is going to equal just dot get first dot length. There you go. Now we're going to keep going until the tries is empty. That means we have no more words to try, and if it goes through it successfully, we return true. Now you want to see what are the number of tries we want to do. It's usually, we're going to go through the whole thing, so it's going to be tries as size, and we're going to try for each word in try. So t equals 0, t is less than the number of tries. Oh boy, and that's going to annoy me. There you go. T plus plus. So we're going to go through each of the words and the number of tries, and then here's the situation we're going to compare. So if, oh, I forgot. Let's see here. So we're going to compare the first word, which is going to be matches.getFirst, or we're going to compare it with the last word, which is going to be matches.getLast. There you go. So, oh, and let's see here, string actual. It's going to be tries dot pull from here. So we're going to pull the word from tries to compare with first and last. So let's see here. So what this exact one difference does, so first we're going to calculate the number of differences. It's going to be a straight up for loop of for int in the character index of the word. Character is less than length, which is the length of each word, which is the same. And now we're gonna say, like, okay, if target dot the character at the character index, it does not equal the actual word dot the character at that index, then we want to increment the diff plus plus. And we want to return, if it's true, there should only be one difference, so difference should equal 1. If it doesn't equal that, then this statement, in the comparison we're doing here for each word, it's going to be false. But if it is exactly one difference, then we definitely want to remove it. So in this case, it's going to be, oh my gosh, first, so first we're going to do, sorry, let's just use that helper method we used right here. Exactly one difference. First actual, and we'll go to the length of the list. And we also want to try this with the word at the back of. By the way, the reason why I compared the first and the last is because that ensures that there will be only at least one word that has one exact difference. Like, for example, each word has at least 2 other words that are exactly one difference of each other. So that's why hence it's a linked list. You can see there's a relationship between its neighbor on the left to its neighbor to the right. But there's always in a link that's going to be 2 words that has only one other string that isn't one difference of each other. This is why a linked list matches with the situation. Now, instead of this being first actual length, it's going to be comparing with the last actual length. Now, if there is exactly one difference between the first and the last letter, in this case right here, matches, I'm going to offer to the last part of the list the actual word, and then we start again from the beginning. And if it matches with the first word, I want to offer the word to the front of the list, and then I'll break it off right here. Now else, let's just say that, let's say, okay, so exact one doesn't work out. What can we do here? That means that the word doesn't work. We'll just offer it back to the tries again. We'll try that word later on in the future. Maybe it might work with a different word. And now, once we're done for looping through all the words we're going to try, now we have to note that if there is no match right here, like let's just say we can offer to the matches, like what never occurred, then if number of try, that means that the size of the number of tries didn't change, and if that happens, equals tries.size. If that happens, we have to return false. That means there's no words here that I can remove to add it to rearrange in the order of the elements that they're a pair of each other. Okay, this looks good so far. I'm just taking one quick look. This you could tell could take about on space O2 of n actually, because I'm creating two linked list data structures. I have a feeling that this could be k n factorial, which is going to be the words. But since that, like the number of iterations we go through the list, it's going to be n, and then it'll be n minus 1 and n minus 1 through each of the words until there's no match. Worst case scenario, it's going to be maybe about n factorial plus n, because we're loading all the words into a linked list into this helper method right here. And n factorial plus n, well, it's going to be n factorial times x, where x is the number of characters in each word. Well, actually, what am I doing? I don't even know if this works. Okay. Set this here. Small, tiny. Hello guys, I found out why the problem occurred. So I did put this at first, at last, but I don't think it makes a difference if you choose offer first, offer last, or at first, at last. What matters is that for each of their tries, you have to make sure that I placed mines accidentally right after this part right here, which means that I'm actually using the same the string that I'm trying. To see if there's any differences. When actually I'm supposed to put it right here for number of tries, I always want to pull in a string from the tries linked list. That's why it was not working. So now I'm going through number of tries. I'm actually comparing that word with if it has exactly one difference with the first word or the last word. If it does, I add it to its respective position to show that it has a relationship with its neighboring word of a difference of one letter in its respective position. And if it never changes after we went through all the tries, that means it returned false. Otherwise, we return true if it successfully goes through that whole linked list of relationships. All right, guys. I hope this makes sense. Please like and subscribe if you like this type of content. And if you don't, let me know what sort of questions I can help you with. And let's hope that I can solve it. Yeah, take care. You guys, good luck in your interviews.